louder than usual. So we don't see anything in catalysts, so we don't have anything written above the arrow, nothing to indicate that any catalysts are here. So there are no catalysts. No catalysts. But we have intermediates. Intermediates are formed in step 1, and they're used in the next step. They're formed in step 2. They're used in the step after that. Let's just go short version. Intermediates, and we will list them by formula. So we have this intermediate made in the first step.
Why do the O's not look too long? Why is it
Yeah, it's a good question, and what? No, it's not 2 ions either. It's an intermediate, and the reason that I think that it's separated out is because it's about to break. I can't really explain that one for you. It's just the way I've always seen it written. It doesn't really follow what we do. And our other intermediate here HOPR. Over and over. Those are the 2 intermediates. Everything else is one of the original reactants, HBRs, O2s, and then everything else over here is products. So no catalyst, 2 intermediates. So we're looking at the bottom to the left of the table. While the rate law for the overall reaction can only be determined experimentally, the rate law for each elementary step can be expressed by its molecularity. And in case that's a few too many words for you, it's easier than that. So the rate law for the overall reaction is simply the rate law for the rate determining or the slow step. So that last sentence said the rate law for the overall reaction, this one, is the rate law for the slow step. This one right here. So we're talking about the slow step. That's the one that we're interested in. The slow step is the one that determines the rate law of the overall reaction. So which step is the rate determining step? You can write it step 1, just next to the question. What is the rate law of the overall reaction? And this is the nice thing about looking at elementary steps. And imagine back to stoichiometry where we have this balanced equation. And we don't normally write 1s, but everything here is 1. The rate law for an elementary step matches the stoichiometry. So if, remember we were writing out rate equals K, here's concentration of HBr, and it was to the X, and then it was concentration of O2 to the Y. We don't have to do that here. Here's how it's going to be different. The orders match the stoichiometry, which means that HBr is 1 because its coefficient is 1. O2 is 1 because its coefficient is 1. And this is the rate law for this reaction up here. So that's how we can use elementary steps where we're making intermediates to find the overall rate law for the reaction. So again, why is this one determining the rate law for that one? It's because for some reason this bakery only has 1 oven, or we waiting on this guy. This guy is the rate determining step, he's the slow step, it's the one that is determining the order of the reaction. Take factory, bakery,
I can understand a bakery, well, I understand a bakery. One, but you said a factory. With all some of that factory, this is the most important.
I'm glad we're having the debate between bakery and factory. I should have been more prepared.
It's also really small, like,
It's,
I've also never heard of being called a cake factory.
what is a cake factory?
Maybe
How many
they
cakes do
bake
you
on
eat?
your house. Oh. Okay.
So this is how I'm gonna make YouTube famous. I'm just gonna let you guys have the conversation.
We need to talk about the water as well. No, because.
Yeah, we did.
No.
Like test out our theory.
No,
So water
because
can
We
make
did
things
lab.
wet,
I love
right?
when you use
So
Yes.
how can it not be wet?
I
It
have
makes
one
it
of
a-
paper weighs.
Got a good point. It's yes and no.
It's yes. Don't tiptoe around the answer.
No, it's yes, but I thought
Hayden came in like 2 or 3 weeks ago after school with somebody else and asked me a question. And I gave him the long version and the short version. Short version was yes. All right. Now look at this table. And I'm not going to draw out the whole thing. For the first row, it says molecularity is 1. And you have that part filled in. You also have the elementary step, A, yielding products. What is the rate law for A yielding products as the elementary step, the slow step? So I guess I will write the reaction because I'm getting a lot of stares. If this is my slow step for a reaction, what is my rate law for the reaction? Rate equals K times the concentration of A to the first power. The next one, it says the molecularity is 2, A plus A yielding products. So we have rate equals K times, it would be really weird to write a concentration A to the first times concentration A to the first. So we'll just put them together. Concentration of A to the second power. The next one, it says the molecularity is also 2. It just means that there's 2 molecules that are reacting. A plus B yielding products. What is the rate law? Rate equals K. Concentration of A. First power, concentration of B to the first power. So third one, I really am going to stop writing the reaction now. We have A plus A plus A. The molecularity is 3, that just means there's 3 molecules involved in the reaction. What is the rate law for this one? What's my order of the reaction? Next one, the molecularity is also 3. We have A plus 2B. Rate equals K, there's concentration of A, what's the order? Concentration of B, what's the order? And last one, also molecularity of 3, we have A plus B plus C yielding products. Rate equals K, what's the order? What's the order? So the rate determining step, or the slow step, elementary step, whatever you want to call it, is the one determining the order, and it's coming from the stoichiometry of the slow step. This always shows up on the AP exam. Anyway, that's just a heads up, it'll show up. All right. Questions so far? In example 2, the following mechanism is proposed for a reaction. Step 1, NO2 plus chlorine yields NO2F plus F. Step 2, NO2 plus F yields NO2F. So, Megan, there's a huge inconsistency here. This one's not NOOF, it's NO2F. I don't think it makes a difference here. But inconsistencies. Okay, so we have step 1. And step 2. Consider the potential energy diagram on the right. It's already filled out for you. That's good because there's a lot on here. Which step is the slow step, and how can you tell? So if you're looking at this, I'm going to draw a rough sketch, not a very detailed one. Comes out, goes up, and then something like this. Which one is the slow step? Right there. The first one. So why do we think it's the first one? Larger width. Here's what it is. The activation energy. It has a greater activation energy. And so for this one, which step is the slow step? How can you tell? Step 1 has the larger, and this is activation energy. Right. Step 1 has the larger activation energy, which tells us this one's going to be the slow step. 2, write the equation for the overall reaction. So, what are we looking at here? First off, what are my intermediates? Just the fluorine, the common fluorine. And so let's put these two things together. The overall reaction, we have 2 NO2 plus 1 fluorine yields 2 NO2F. Identify any catalysts or intermediates. It says nothing about catalysts. We already identified the intermediate. The intermediate is the atomic fluorine, which is the F. Write the rate law for the overall reaction. order for nitrogen dioxide. Is that first order, this one? Okay. Low fluorine. First order. Comes from the slow step, the stoichiometry of the slow step.
Will the slow step always have both of the reactants in it? It's like, what if the
Not
slow step
necessarily.
is step 2?
Yeah, not necessarily. And so if it had been step 2, then because the atomic fluorine wasn't one of our original reactants, so it wouldn't show up in the overall reaction. So yeah, if that were the slow step, it would have been rate equals K, concentrated NO2.
So you don't need the F.
And that is operating on the premise that step 2 was the slow step. Really, about that, you would probably say that fluorine is 0 order. Just 1. It's not uncommon to see a reaction mechanism in which there's a fast equilibrium before a slow step. The rate law is a combination of both steps. Sometimes this guy gets ahead of himself. We haven't talked about equilibrium at all, and it doesn't come up in the problem sort of test. We might have to revisit this in a couple months.
Yeah, we can.
Stop the tape for that one.
Yeah, we can chemistry terms.
Yeah, let's stop there.